Hello YouTube. I'm going to make a video today about how I built this little aluminum windmill. You may have gotten here from a solar shed or a tiny house link. My goal here is to show you how I built a wind turbine, not to teach you how to drill or weld or etc. There are lots and lots of very good channels to do all those things. I'm also not much of a videographer, so I will do some still photos here and we'll discuss it over that. This is the mechanical half of part 1 of 2 of the video. Part 2 will be about the electronics, so let's get to it. This is the motor. It's an eBay special. It's an ES8098. It's 120 volts DC. It will make 18 volts DC at 300 RPM. That's no load. And it is a whopping 35 watts of output. Here you can see a 1/4 inch piece of aluminum laid out for the hub, and the remaining piece would be for the motor bracket itself, and the piece of round stock will be the hub adapter. Here is the motor in its bracket all welded up, and you can see the 2 marks on the shaft and the through drilled hole in the shaft that'll be used to mount the rotating assembly later. The 2 marks are going to be where it's going to be cut. Shaft is hardened, so you'll have to cut it with a grinding disc. Okay, so Electronic Dog here, my buddy, made a really fantastic video about low wind speed start short blades. He gives you almost enough information to make your own blades. I gotta hand it to him though. And in the video, he says you need to bend the blades to 6 to 8 degrees, and then I'm not sure if it was just for show or what, but he bent his blade to like 45. So I don't know. So we're going to bend a set of blades just like his. These are going to be 12 inch. If you watch his video to the end, it shows, or rather he says that a shorter blade will start even slower. So what we've done here is we've clamped that to the edge of the welding bench with a piece of channel iron, and the steel colored piece there is, I think it's a filing cabinet divider. We're gonna put that underneath the edge of the aluminum blade and bend it up to about 12 degrees. You can see in the background the angle finder, and this is what the outcome of that process looks like. If you can see, I clamped the shorter axis of the bend and bent the longer axis, so we had a better mechanical advantage. The cardboard template there is for a high-speed blade, which we're not going to talk about during this video, but that's a template for later. And you can also see the 1/4 inch hub is cut and ready to be drilled and tapped. Here is the 1/4 inch thick, it's roughly 4.5 inches in diameter, laid out for 3 screws for each blade. They're number 1024. And I use stainless hardware for this whole project. Stainless and aluminum will gall over time, especially in the weather, and so copious amounts of Loctite will help it keep from galling in the weather. Here is the hub adapter welded to the hub. I used an 1/8 inch drill bit, a pilot hole through both pieces to keep them aligned while I welded. And then I'll go back and counterbore the motor shaft, the top of this picture, to 8 millimeters. Here is the blades and hub assembled. Not much to say here. Again, stainless steel hardware with copious amounts of Loctite. Here's Steve Robertson's video on how to balance wind turbine blades. He makes a very good 7-minute video about this. Long story short, measure from tip to tip on all blades to keep them even, and then he has it hanging from a string there from, I think, his porch. And I did the same thing with my rotating assembly, and you can see my filthy dirty workshop in the background there. So this is the result of the balancing. I used a couple of nuts and 1 extra screw on that side of the assembly, and that balanced it out rather nicely. You can see the counterbore for the hub as well, or for the motor shaft rather as well. Here is the tail. The tail is based on a Northrop Grumman YF-23. Not that aircraft has anything in particularly interesting, it's just that it looked really cool. I'm pretty sure I'm violating some laws of physics by just making up my own tail, but at any rate, I balanced the entire wind turbine assembly, and that length of tail balanced out the rotating assembly in the front and the motor and everything else. So don't mind that extra hole in the back of the furling tail there. That's for speed. This is Belgrade Machine. His video on how to make wind turbine out of a stepper motor. I actually tried this, and I'm sorry to say that it does not work. However, the rotating, or rather the pivoting design that Belgrade uses here, I borrowed for my use. Those are just bearings on a piece of 1/2-inch threaded rod. It's 6 inches long, and the washers are small enough in diameter that they allow the bearing to pivot freely. Not much more to say about that. This is the pivot thrust washer. It's made from Tyvar, which is a piece of stock I had bought for another project and never used. Turns out it's pretty neat shit. It's ultra high molecular weight polyethylene. Say that 3 times fast. And it has good wear resistance, so I lucked out here, and I made that 1/4 of an inch thick. Here you can see the thrust washer, the rotating or pivot assembly, and the tail bolt, which will also be used as a rotation stop. In this photo, the pivoting assembly goes down inside that piece of 1 1/4 inch Schedule 40 water pipe, and then the 2 drilled and tapped holes in the water pipe keep it from blowing out of the top of the pipe, I guess would be the, they keep it held in the pipe, and the top one acts as a rotation stop. The tail bolt hits that bolt, and so that's what we use for a rotation stop. This is the aluminum flat sheet layout to make the housing cover. Whenever you do something like this, you want to add the thickness of the material to your dimensions, so that way that'll allow for the bend. Well, I bent this the same way as the other blades, with a piece of channel iron on the edge of the weld bench. If you're going to bend something in 3 dimensions, like a box or a cover like this, always start your bends before you complete them. Otherwise, you're not going to be able to bend the final piece. And that housing fits nicely on my little anvil. I think that anvil came from eBay. I think it's 11 pounds. There is the finished housing. The edges are not TIG welded in this video, but I TIG welded the edges, those back edges together. This is the beginning of the mounting bracket for the shed. It was nice to go back to steel. I'm not much of a welder, but steel's so much easier. And here you can see it mounted on the side of the shed. The 1-inch spacer was so that when the pole gets bolted into the U-bolt, it doesn't mash my drip edge, which makes sense, huh? Here is the rotating assembly mounted on the motor and its bracket. The motor shaft is 8mm, and they don't make a fractional drill that size, and so there was a little bit of wobble in that. So I put a dam around the bottom of the hub with blue tack. It's like for putting posters on the people's walls or whatever, so it doesn't leave marks. And then through the 1/8-inch pilot hole, I filled that full of super glue, figuring that it wouldn't stick to either metal, but it would, it would make up the space. And I put a couple of nuts and washers on that to keep everything balanced and level. And I came back a day later, and the super glue was still wet. It was just a horrible mess. I highly recommend you do not do that. So I cleaned everything up and re-leveled it and got everything balanced back together. And through the 1/8-inch pilot hole, I put just a 2-part epoxy. Mixed it a little thin with a little less hardener in it, and allowed it to dry, and it is the bee's knees. I hope I can get it back off, but if not, it's okay. So I have a little video here for you to watch on the balance of this assembly, and there's no audio to it. It's a little dark, I'm sorry, but it's a few minutes long, or a few seconds long rather. Here I'm showing you the electrical connection out. That'll be next video. And you can see the hardware and everything assembled. You can see that little puddle of epoxy. And I'm going to give her a little spin here. And she spins very nice, and then has one little cog back, and that's her. So stay tuned for part 2, which is the electrical, and I'm going to show you a different way to do wind. Most people use a dump load, and with this only being 35 watts, we can't afford to be dumping any energy. And so we're actually going to let it run all the way up to 40 volts with some really cute electronics that are going to let almost double the voltage in to power your batteries. But that's all for now. I hope you enjoyed. Please comment and subscribe. Otherwise, stay tuned for part 2, which will be the electronics.